Hello
Hello.
everyone, I am Precious Day, roll number 820 CSC 261, and today we are going to learn about clustering. So what is clustering? Clustering is a type of unsupervised learning method of machine learning. It is a classic data mining technique based on ML that divides groups of abstract objects into classes of similar objects. Clustering is the task of dividing the population or data points into a number of groups such that data points in the same groups are more similar to other data points in the same group and dissimilar to the data points in the other groups. It is basically a collection of objects on the basis of similarity and dissimilarity between them. So, for example, let's take two groups, group A and group B. So, there are some data points in group A and some in group B. So, the characteristics of the data points in group A will be same, but they will differ from the characteristics of data points of group B. Uses. So, what are the uses of clustering? Clustering techniques can be used in various areas or fields of real life example, such as data mining, web cluster engines, academics, bioinformatics, image processing and transformation, and many more, and emerged as an effective solution to the above mentioned areas. So let's talk about recommendation engine. The recommendation system is a widely used method for providing automated personalized suggestion about products, services, and information where collaborative filtering is one of the famous recommendation system and techniques. In this method, the clustering method provided an idea of like-minded users. The computation or estimation as data provided by several users is leveraged for improving the performance of collaborative filtering methods. And this can be implemented for rendering recommendation and diverse applications. For example, the recommendation engine is broadly used in Amazon, Flipkart to recommend products and YouTube to suggest new videos or songs. Essentially, each cluster will be assigned to specific preferences on the basis of customers' choices who belong to the cluster, and then within each cluster, customers would receive recommendation estimated at the cluster level. Next, market customer segmentation, a process of splitting the target market into smaller and more defined categories, is known as market segmentation. This segments of customers or audiences into groups of similar characteristics like their needs, location, interest, or demographics, where target and personalization under it is an immense business. For instance, a business is looking to get the best return on investment. It is necessary to target customers in a proper way. If wrongs are made, then there is a high risk of not making any sales and ruining customers' trust. So, the right approach is looking at specific characteristics of people and sharing campaigns with them that are also helpful in engaging with more people of similar behavior. Clustering algorithms are capable of grouping people with identical traits and prospects to purchase. For example, once the groups are created, you can conduct a test campaign on each group by sending marketing copy, and according to response, you can send more target messages to them in the future. Under the customer segmentation application, various clusters of customers are made with respect to their particular attributes. On the basis of user-based analysis, a company can identify potential customers for their products or services. Clustering methods enable us to segment customers into diverse clusters depending on which companies can consider novel strategies to apply their customer base. Next, social media analysis (SNA). It is the process of examining qualitative and quantitative social structures by utilizing graph theory and networks. Here, the mapping of social network structure is arranged in terms of nodes and the edges or links that connect them. Clustering methods are required in such analysis in order to map and measure the relationship and conflict amid people, groups, companies, computer networks, and other similar connected information or knowledge entities. Clustering analysis can provide a visual and mathematical analysis or presentation of such relationship and give social network summarization. Next, search result clustering. It makes groups of similar objects in a single cluster and renders to you that this provides results of search data in terms with most closely related objects that are clustered across the data to be searched. Depending on the closest similar object or properties, the data is assigned to a single cluster, giving the plethora sets of similar results of the users. In simple terms, the search engine attempts to group identical objects in one cluster and non-identical objects in another cluster. Biological data analysis, medical imaging analysis and identification of cancer cells. One of the means to connect analytical tools with biological content is biological data analysis for a heavy and extended understanding of the relationship identified as to be linked with experimental observations. Biological data is structured either in the form of networks or sequences where clustering methods are significant for identifying profound similarities. Clustering helps in extracting useful knowledge from huge data sets collected in biology and other life sciences realm as medicine or neuroscience with the fundamental aim of providing prediction and description of data structure. Using clustering algorithms, cancerous data sets can be identified. A mixed data set involving both cancerous and non-cancerous data can be analyzed using clustering and algorithms to understand different traits present in the data set. Depending upon algorithms, produces resulting clusters. Let's talk about types of clusters. So there are mainly two types of cluster, hierarchical clustering and partitional clustering. And hierarchical clustering gets divided into two more parts. So hierarchical clustering, it depends upon the hierarchy. These clustering methods create a cluster having a tree-type structure where each newly formed clusters are made using priorly formed clusters and categorized into two categories. Agglomerative bottom-up approach, divisive top-down approach. The Agglomerative approach, also called the bottom-up approach, starts with each object forming a separate group. It successfully merges the objects or groups close to one another until all the groups are merged into one. The topmost level of hierarchy or a domination condition holds. The divisive approach, also called the top-down approach, starts with all the objects in the same cluster. In each successive iteration, a cluster is split into small clusters even until eventually each object is in one cluster or a domination condition holds. Some common used algorithms like bridge or chameleon. Partitional clustering. Partitional clustering algorithms are the form of non-hierarchical that generally handle static sets with the aim of exploring the groups exhibited in data via optimization techniques of objective function, making the quality of partition better repeatedly. This clustering method classifies the information into multiple groups based on the characteristics and similarities of the data. It's the basic analysis to specify the number of clusters that has to be generated for the clustering methods. In the partitioning method, when database T that contains multiple n objects, then the partitioning method constructs user-specified k partitions of the data, in which each partition represents a cluster in the particular region. There are many algorithms that come under participate partitioning methods. Some of the popular ones are k-mean, PAM, Clara algorithm, etc. K-means clustering. K-means clustering is one of the simplest and popular supervised machine learning algorithms. Typically, unsupervised algorithms make inferences from datasets using only input vectors without referring to known or labeled outcomes. A cluster refers to a classification of data points aggregated together because of certain similarities. You'll define a target number k, which refers to the number of centroids you need in the dataset. A centroid is the imaginary or real location representing the center of the cluster. Every data point is allocated to each of the clusters through reducing the in-cluster sum of squares. In other words, the k-mean algorithm identifies k number of centroids and then allocates every data point to the nearest cluster while keeping the centroids as small as possible. The means in k-means refer to averaging of the data, that is finding the centroid. It is one of the most commonly used algorithms for partitioning a given data set into a set of k groups, that is k cluster, where k represents the number of groups. It classifies objects in multiple groups, that is clusters, such that objects within the same cluster are as similar as possible, that is high intra-class similarity, whereas objects from different clusters are as dissimilar as possible, that is low interclass similarity. In k-means cluster, each cluster is represented by its center, that is centroid, which corresponds to the mean of points assigned to the cluster. The basic idea behind k-means clustering consists of defining clusters so that the total intra-cluster variation, known as total within cluster variation, is minimized. Before k-means, this is the normal graph the with the data points, but after k-means, these data points are divided into three groups, and these three groups within these groups, the data points have similar characteristics, but if we compare The group blue with group green, they will have different characteristics, or group green with black. Steps involved in k-means clustering. The first step when using k-means clustering is to indicate the number of clusters k that will be generated in the final solution. The algorithm starts by randomly selecting k objects from the dataset to serve as the initial centers for the clusters. The selected objects are also known as cluster means or centroids. Next, each of the remaining objects is assigned to its closest centroid, where closest is defined using the Euclidean distance between the object and the cluster mean. This step is called cluster assignment step. After the assignment step, the algorithm computes the new mean value of each cluster. The term cluster centroid update is used to design the step. Now that the centers have been recalculated, every observation is checked again to see if it might be closer to a different cluster, or the objects are reassigned again using the updated cluster means. The cluster assignment and centroid update steps are iteratively repeated until the cluster assignment stops changing, that is, until convergence is achieved, that is, the cluster formed in the current iteration are the same as those obtained in the previous iteration. This one of the question. We have given data points and we need to divide these points into two clusters using K-means algorithm. So step 1 is we are choosing any random number. Step 2 is we are taking the centroid of K1 and centroid of K2. Step 4 is again where we need to take the centroid of the new K1 and new K2. So this time the centroid is 5, 20. And then we need to again take the new centroid of the new K1 and K2. And the when the new centroid will be same as the previous centroid, we'll say that we made two clusters, and final cluster points for K1 is 2, 3, 4, 10, 11, 12, and for K2 25, 30, and 20. So this is the question number 2. Here we are given a table with height and weight as the column. So the question is divide the given sample data into two clusters using k-mean algorithm and Euclidean distance. So Euclidean distance is written down here, which is root xh minus c1 का whole square plus x w minus c2 का whole square. So xh and xw are the observed value which we got from the data set, and c1 and c2 are the centroid values. So step one is that we'll choose a random number from the data. So we choose for the R1, we choose height as 185 and weight 72. Same for the R2, we picked up a random number 170 and weight 56. So the centroid values for R1 is 185,72 and for R2 is 170,56. Then then we did Euclidean distance for the R with R3. So we compared R3 with R1 and R3 with R2. So so we applied the formula, and for with R1 we got 20.8 and for R2 we got 4.48. So 4.48 will be taken as the answer. So R1 will K1 will remain same, but K2 will be R2 comma R3. Same with the centroids, C1 will remain same 185 comma 72, but C2 it will change. So now the new C2 is 169 comma 58. Now we did it same again R4. So we compare the value of R4 with R1. So the value is 6.32 and we did it with K2. So the value is now 14.14. So we'll take 6.32. So K1 will change and now it will become R1 comma R4. So of course the centroid will change once again. So now the new centroid for now new centroid C1 is 182,70, but there will not be any change in the C2 value. So the centroid will remain same, that is 169,58. Then we did it again with R5 and then we'll do it, and the final cluster data points that we will get after doing it is K1 will be R1, R4, R5, R6, R7, R8, R9, R10, R11, R12. And for the K2 we got R2, R3. So I'll show you once again both the questions. This was question 1. The question here was that we are given two cluster, and we have to divide these points into two cluster using k-mean algorithms. I hope you can understand it. These are the advantages. It's really simple to implement. Scales to large data sets, guarantees convergence, can warm start the position of centroids, easily adapts to new examples, generalizes to cluster of different shapes and sizes such as elliptical clusters. This advantage is difficult to predict k-value. With global cluster, it didn't work well. Different initial partition can result in different final clusters. It does not work well with clusters in the original data of different size and different density. That's all for now. Thank you everyone for watching this video.